Eddington up until I started the research on him, but I think he's a rather interesting individual, very fascinating, a very prominent figure, no doubt, moving into the early parts of the 20th century. But like I say, it's always an honor to present before you. I hope everybody can see the screen. And I like to consider this a discussion, so please interrupt me with any questions. I may see a hand held up. I've got the top bar up there, or just activate your mic and scream at me, and we'll do it. Like I say, this shouldn't go on too long. I don't want to let it drag too much. But please interject if you have a question or if you see something that I have glaringly wrong. Anyhow, Sir Arthur Eddington is probably one of the more, I guess famous is probably the best way to put it, but certainly in the UK, in Great Britain, probably one of the most famous astronomers, physicists, mathematicians, and I would say probably a scientist. Certainly not. I would consider him on par with Newton, certainly, especially considering how he was able to advance the science of astronomy. And there's actually a couple of other things he did, and this is why I found him to be quite an interesting fellow. But we'll go ahead and jump right into it. If I can get my controls to, there we go. Okay, so basically I'm going to cover a little bit of one of the interesting things, and I've made a couple of presentations on astronomers, but this is the first one that I've been able to provide in relatively modern terms. Leading up, I was looking at some of the ancient astronomers, and of course, needless to say, there isn't a whole lot of information about their lives other than the fact they were probably born about this time, they probably died then, but very little else with respect to their life outside of what they're known for and their notoriety probably in the profession. But we do know a little bit about I'll refer to him as Sir Arthur Eddington. We do know a little bit about his life because, of course, this is, he was born in the latter years of the 19th century, but his most prominent work was done just before World War I, and probably
did
just
you
prior
mean to advance your slides?
I'm sorry?
Did you mean to advance your slides? I think.
Not yet.
Okay.
You should be looking at one that says Life, Education, Work, Legacy.
Just wanted to make sure I wasn't stuck on a stuck screen.
No, you're fine. Hey, I appreciate it, man. But like I say, it's kind of nice to be able to deal with somebody that you can get. There's a little more information available about their life. I'll cover his education, which is some pretty good detail there, and certainly his work, his legacy, and of course we'll finish off with the references. To start off, he was born shortly after Christmas in 1882 in Kendal, Westmoreland, the Cumbria region of England. If anybody's familiar exactly where that is, please pipe on. But I'm not familiar with the region as much. But his parents were Quakers. His father, Arthur Henry, was a Quaker school headmaster, and his mother, Sarah Ann Stout. The unfortunate thing, very early in his life, he was 2 years old when his father died due to the typhoid epidemic that swept through the UK in the mid-1880s. And so it was just his mother, his sister Winifred, who was a little bit older than him, and himself. And they ended up moving from their original home where he spent the first 2 years of his life to an address, Varzin 42 Wallescote Road in Weston-super-Mare. The reason I mention that is because the home actually has a plaque on it. There's a commemorative plaque where Sir Arthur probably spent, I'm going to say approximately at least the first, I would say 12 years of his life, with the exception, 16 years of his life, with the exception of those first two. I'll come to it later, but you'll notice some things I keep in a chronological timeline, other ones I don't. But with respect to notable things, and there's certainly a lot more about his life, but more of his course related to his education and his work. But one thing that came out, and this can be related to his Quaker upbringing. I don't know if he was, in fact, practice, what they call it, the Society of Friends. I don't know if he was a practicing Quaker. I suspect that he might have been, but always maintained, the standards and the church teachings for the most part, because he was a pacifist, and he considered himself, in fact, he made application during World War I. There were various levels of conscription, or what we might call a draft, that occurred moving in through World War I once it started. And the British certainly had different levels as they needed more and more personnel. Of course, I think most folks are aware that for the most part, World War I pretty much nearly killed off an entire generation of British men, not to mention, French and German to a certain extent too. But Great Britain was particularly impacted. And so there were various times leading up to the war and during the war that there were different levels or tiers of conscription. And so, certainly Eddington had to deal with this a couple of times. For the most part, he wanted to pursue an application as a conscientious objector. When in point of fact, that wasn't really a consideration under British law. And what ultimately happened was, both owing to his work and some of his colleagues and some of his supervisors, because at this time he was actually working, they actually put forth the fact that his work was essential, not necessarily to the war effort, but he was performing essential work and really should be excused from military service. But for the longest time, Eddington didn't see it that way. He saw himself as a conscientious objector. Nonetheless, he never did have to serve. The one thing that he did consider, he was willing to go into service as a non-combatant working in the ambulance service. So, and of course, one of the most significant things about his life, he was knighted in 1930 and received the British Order of Merit in 1938. These are pretty rare occurrences. I mean, some people may think they hand out knighthoods to everybody, but I think particularly in the early parts of the 20th century, this wasn't necessarily so. And most assuredly with the Order of Merit, my understanding is there were only a limited number orders of merit that were living at any one time. And so this was a pretty rare occurrence. Of course, as people died off, there would be further selections down the road, but it wasn't like there's a couple of hundred people hanging around with orders of merits. It is somewhat limited. And of course, the big thing is you get to have the OM after your name. But these are some of the significant things that occurred in Eddington's life before his education, and of course, much after his education going into his work. He was homeschooled for the most part for 3 years, and then, it was homeschooled, and then followed by 3 years of prep school, which occurred when he entered Bryn Mawr School in 1893. So at this time, 84, he's basically 9 years old. He excelled in mathematics. And one thing to understand, I mean, as we get talking about this, I think there really is three main academic areas that Eddington excelled in. First was mathematics, then came physics, then came astronomy, and to a certain extent, maybe philosophy after that. But during his formative years, mathematics and English literature, and of course, he was smart enough. His scholarship, his brains were basically enough to get him to Owens College, which later became the University of Manchester. And he started that at 1898. He was only 16 years of age, and this was a pretty rare thing. It wasn't something that was normally accepted that someone not of age, say, I'm going to assume around 18 or 19, not of age would go into a university at that point. This was a pretty rare occurrence, and there were a number of hoops that had to be jumped more or less for this to happen. But nonetheless, even at the young age, he continued to excel general studies for his first year, and his initial area of study was physics. He was significantly influenced by a couple of notable teachers. For those that may know the physics world, you may know these names. I mean, they were certainly new to me, but Arthur Schuster and Horace Lamb, they had their areas of responsibility. Schuster with respect to the discovery of antimatter, not that he necessarily discovered it, but certainly the concept in that regard. And then Horace Lamb, who authored several texts in classical physics that were used by a number of students over the years. Education continuing, he secured his Bachelor of Science in Physics, which was awarded in 1902, and this would have been from University of Manchester. His studies at Manchester merited further scholarship, and he ended up at Trinity College in Cambridge. There he was tutored by Robert Herman to become the first, and this is another thing. I mean, this was really a big thing at Cambridge, to become the first ever second year student to achieve senior wrangler status, top undergraduate math student. He was the top math student at the University of Cambridge in his second year. Typically, the wranglers were generally, well, what we consider in their last year, second to last year of studies, but generally their last year of studies. So this was significant. And it's significant for another reason, is that typically, you'll see this in one of his work assignments, This basically got him into one of his first positions. This status as the top math student at Cambridge. But anyhow, he received his Master of Arts in 1905, and I'm trying to remember, it was just, I suspect it might have been the year after, either side of 1905. I don't have the date, but I believe he also received a Master of Science. Outside of his studies, nice thing to learn, he had a little bit of an athletic background. He was a footballer when he was at Owens at University of Manchester. Footballer, I'm not sure if that refers to soccer or rugby, or it could be both, but I'm not sure which one. Hockey player, here again. This was when he was working his first job in an observatory, and we'll get to that very shortly. Whether it was field hockey or ice hockey, not sure. He was a swimmer, a golfer, and he was an avid and lifelong cyclist. That's one thing that I was able to establish. Where he picked that up, I'm not absolutely sure. But outside of his studies and his academic work, he did have a little bit of an athletic background.
So,
go ahead.
Correct me if I'm wrong, Doug. On those ages, he essentially earned one of the top honors at Cambridge at the age of 18, and then graduated with a master's at the age of 21, which is.
Well, I'm backing this up a little bit. Okay, so he got his bachelor's when he was 18. Looks like, yeah, his Bachelor of Science, because he was born in 84. So if he got it in 1902, he'd be 18. And then he received his master's in 05. So yes, he would have been 21.
So then he got the Wrangler status when he was in 1900. Then going by this time,
the Wrangler status probably occurred, I'm going to say, second year student,
which would put him at 16. Or no, 18.
Yeah, this would be at Cambridge, not when he was at Owens. So I suspect it was a little bit, I'm going to say it was probably 1903, 1904. So he may have been almost 20 at that point.
Okay.
Because when he had his Bachelor of Science in Physics out of Manchester in 1902. Then he went to Cambridge.
Oh, okay.
And it was that second year at Cambridge when he achieved this Wrangler status, the senior Wrangler status. So at the time, I'm guessing he would have been, based on this, about 19 or 20.
Yeah.
So
regardless, that's very
regardless
impressive.
of when it occurred, even if it occurred 4 years later, this I mean, with respect to academic prowess in science, and here you certainly have Cambridge, you got Oxford, we're talking Cambridge here. This was a big thing. So with respect to that, and it sort of makes sense when you see the type of work and the type of things that he did later in his life. It certainly makes a lot of sense, but this certainly put him on a very high level going into his master's studies, and like I say, is going to provide the impetus probably pretty much for his first job, which happened to be chief assistant to the Royal Astronomer at the Greenwich Observatory. Okay, and this started in January 1906. And this is why I put in this note here, between 1835. So there was a lot of history, legacy with this. Between 1835 and 1930s, all chief, there was generally one chief and one first assistant, but over the years, there might be more than one first assistant. There would generally be one chief, but there might be 2 or 3 first assistants, were exceptional math graduates. A lot of them were this senior wrangler. So I think that was key to Eddington attaining the job at Greenwich as chief assistant to the Royal Astronomer pretty much very shortly right out of college, at least his master's studies. One of the things he worked on, he was put to work on measuring the parallax, and I think it was for Eros, for one of the asteroids. And then he also developed a new method based on drift of background stars that resulted in the Smith Prize, which here again is another big thing.
Hey, Pete?
Yes.
He developed a new method for what?
Based on the drift of background stars. Doug, I'll be the first to admit it. I didn't fully understand it, but basically it was a method, using the parallax method, using photographic plates. They had glass plates, using the parallax method to adjudge distances.
Okay,
he developed another method for adjudging distances based on the drift of background stars. Okay. Precisely how the mechanism works, I do not know. So okay. I'll admit ignorance in that regard. So anyhow, so here we have him. So he's working at the Greenwich Observatory, Smith Prize in 1907. And the Smith Prize also included a fellowship to Trinity College in Cambridge. So now you see the transition coming into Cambridge out of the Greenwich Observatory. There was still a number of years, but at one point, and one of the things, and going back to the picture here, this picture you see here is basically the lodgings he had while he was chief assistant at Greenwich. And there's a little plaque. I don't know if you see, there's a little, well, my arrow wasn't showing it, but just on the windows on the bottom floor, there's a little circular plaque just to the left of him. And that, of course, has a plaque about his residence there. He lived in a 2 or 3 room apartment on the first floor. And for a while, I think his mother and sister actually lived with him, I suspect, mostly when he was at Greenwich, not so much later on when he moved on to Cambridge. So anyhow, we get to about 1913, pretty much we've wrapped up his Greenwich time, because he's been promoted as the Plumian Professor of Astronomy and Experimental Philosophy in early 1913, following the death of George Darwin, the son of Charles Darwin, very famous individual, at Cambridge, in Trinity College. This is a very, very exclusive position. I don't have any information on his history at Cambridge prior to that, other than the fellowship. So I'm not sure what led into this. I suspect his work at Greenwich, and certainly, the Smith Prize and a few other things probably didn't hurt exactly what the process was to obtain this chair. But, and then shortly after that, later on that year, he was named director of Cambridge Observatory following the death of Robert Ball, holder of the Louding Chair. Essentially, the Plumian Professor and the Louding Chair were the 2 critical positions for the Cambridge Observatory. So once both these positions were open, he was chosen to fill both of them. Then essentially he became the director of the Cambridge Observatory. And so he's done with Greenwich, moving on to Cambridge. However, going back to Greenwich, while he was there, I was able to tabulate, and I think I say over 200, approximately 243 papers. He was a pretty prodigious, primarily researcher. And I think, later on, I'll say, I don't have a lot of knowledge or information, or wasn't able to find a lot with respect to his teaching credentials, although I know he lectured. I know he talked to a lot of people, and this is something that comes out later. Late, in fact, I'll mention it now, but basically, along with all of his research work and along with all of his writings, in my mind, he was sort of like trying to think now, Carl Sagan or Neil deGrasse Tyson of his time, very much a promoter of science. And this will come out later. You wouldn't think that. You look at this guy, well, he's writing papers. He wrote a ton of books. When did he have time for this? And the fact of the matter is, I think that was an essential part of his work and took up a lot of his time. But nonetheless, so he authored over, like I say, and I think it was upwards of 250 papers when he was at Greenwich, mostly dealing with the theoretical aspects of astronomy. Initially, that was his focus, being that he'd come out of physics and astronomy, most of his focus was on the theoretical aspects. It's not that he didn't do any observations, he certainly did. And there were a couple of key ones that he got involved in, but his primary focus was the theoretical side of both physics and astronomy. But anyhow, you can see the Royal Astronomical Society, he was secretary for 5 years, followed that up with 3 years as the vice president, and then another 3 years as president of that rather august group in the UK. He was elected as a fellow to the Royal Society in May of 1914. Here again, a big, big thing. The Royal Society, of course, recognized significant contributors to science, in the UK. And if I remember correctly, I mean, typically, most of the members are from the UK, but you would see approximately, I don't know if this happened on an annual basis then or now, but you would see about 10% or upwards of 10% of the fellowships being selected would go to foreign members. So there are people outside of the UK that were able to secure a fellowship with the Royal Society. Of course, he was awarded the Royal Medal in 1928 for his work, delivered the Beckerian Lecture in 1926. These are significant events that were covered, primarily in his biography, if you take a look at the Greenwich Observatory site. But yeah, he lectured on the diffuse matter and interstellar space. You're going to find some of his most significant work dealt with the composition, and the processes in stellar evolution. Okay, so we move on to other contributions in work: astronomy, relativity, cosmology, and philosophy. And I sort of backtrack a little bit. The bulk of his work was theoretical work in stellar interiors, including the first true understanding of stellar processes. He was one of very, very few, I mean, just a handful, if that, that proposed theories with respect to how stars develop their energy. Most of his work began in 1916. He was one of the first to propose that nuclear fusion was the main power source for stars. And he also provided a physical explanation of Cepheid variables. He recognized the importance of ionization in stellar interiors with respect to the contribution that radiation pressure along with gas pressure made against gravity to keep stars pretty much in hydrostatic equilibrium. But admittedly, during this time, as these theories were coming out and some of these new ideas were coming out, there wasn't necessarily agreement amongst all the experts. You certainly had, I don't want to say necessarily rivals, but contemporaries, not necessarily colleagues, but contemporaries that disagreed with some of his ideas. And this is just one where Eddington promoted proton-electron annihilation and nuclear fusion processes over the Kelvin-Helmholtz mechanism. And of course, he was pretty much, in a very basic sense, proven to be more accurate with respect to some of his ideas and theories, and certainly with respect to the main energy producer in stars.
What was the Kelvin-Helmholtz mechanism? That's the first time I've come across that.
It's a good question, Connor, and I actually looked at it a little bit, didn't completely understand it. I know it varied a little bit with these, with these basic fusion processes, and I think it had to do more so with the variation of the different types of stars, because certainly, I mean, there were a couple of things that Eddington did with respect to his processes that probably fit the main range, probably, like the main sequence of stars, not necessarily the extreme, although in some cases they do, but certainly, like white dwarfs and red supergiants would have been out that realm, even though those weren't specifically studied. But to be honest with you, no, I'm not familiar with the mechanism, or not enough to talk about it, at least.
Thanks.
Okay, so these are a couple of key dates. Here again, I backtrack. This is sort of like one of those TV shows. You go forward in time, you go backward in time. And so we take a look at some other, and these are key dates, key accomplishments that sort of explain his involvement in different types of work. But one thing, in 1920, traveling to the island of Principe this is off the west coast of Africa, to observe the solar eclipse on May 29th of that year, confirming part of Einstein's theory of general relativity regarding the bending of light. In other words, he was able to observe stars slightly out of position and make the case. And his results weren't very good, but they were good enough for the time to make the case for this. The expedition wasn't an entire success, but like I say, it was good enough. Prior to that, I think he'd actually made a trip. I keep thinking around. This is when he would have been at the latter years at Greenwich, made a trip to Brazil to observe another eclipse. And that didn't go very well. They weren't able to, notwithstanding the poor skies they had, some of the equipment they had, and some of the processes that they had developed really didn't amount to much. They had limited time. They were able to make some observations, but the methods and processes that employed just didn't deliver any good science. So this was a little bit better, but certainly not the best in all cases. But what he wrote about, what he was able to write up and provide, to his contemporaries was good enough to make the case for confirming part of Einstein's theory with respect to bending of light, coming by, the eclipsed sun. It could be observed, and they could actually see this effect a little bit. Eddington, here again, and I mentioned this before, this is around the 1920s, speculated that nuclear fusion processes in stars were the principal mechanism for their energy, hydrogen to helium, hydrogen fusion into helium. In 1923, and this is where we diverge a little bit, he published a mathematical theory to relativity, and this is key, which included a compilation of his lectures on relativity that provide explanations in both lay and scientific terms. And you'll see I have a picture there. There's Eddington and Einstein, and this was a meeting that took place, I think, quite a few years after that, may have been in the 30s. Einstein made quite a few trips to the UK, lectured quite often whenever he was over there. But Eddington was probably one of Einstein's principal proponents with respect to his theory of relativity. You're going to see later on, I'm going to have a little quote here down the road, and I don't know if it's necessarily true, but Eddington was one of the very few, and I think less than a handful, that probably truly understood Einstein's theory. He had the math background, he certainly had the physics background, and this was sort of an area where he branched off a little bit, from astronomy, from pure astronomy, although there were a lot of relationships nonetheless. And he was very much a proponent of, and to a certain extent, Einstein may have proposed the theory, but Eddington is probably the one that made him famous for it, to a large extent, given how much he talked about it and the way he was able to explain it, not only to his colleagues, but to the general population, or at least those that had an interest to a certain extent, because like I say, he could explain it in lay terms also. One of the, outside of his principal work with respect to basic stellar processes, of course, another thing in 1924, he discovered the mass-luminosity relationship for stars. There is something, I'll get, I think on the next slide, a specific value that's related to them, or a relationship. And then in 1926, he publishes The Internal Constitution of Stars, which was, a text that was used for a number of years by generations of astrophysicists with respect to the basic processes that occurred in stars. And if you ever take a look, and I read some of the excerpts, both journal articles and books, and don't get me wrong, I do not understand everything, but I think if I understood just a little bit more, his writing style academically was such that he was a very easy person to understand. I think that's why, he connected with a lot of people, both in academia and outside of academia. And I think that was one of his other very, very true values to the science and to the, proliferation of science, both in the UK and outside. This is one of the things, prior to World War I, when he had just started to work, he was very much in tune with the exchange of information between scientists on the island in the UK and with scientists throughout Europe. And of course, World War I pretty much put the kibosh on that and restricted that. And I think that was, he took, I don't think he felt very good about it, because one of the things, he liked interacting with his colleagues. He liked interacting with his contemporaries and exchanging information. Part and parcel how he ended up promoting Einstein's work so much, because in his work, and I think we go back when we look at his, primarily his position in the Royal Astronomical Society, afforded him the opportunity to read some of the early papers, some of the early works of Einstein. And, like I said, he gained an early understanding of some of the work that Einstein was doing. And so, when Einstein came out with his full theory, it wasn't much of a stretch. And certainly we can understand why he became such a strong proponent of it, or promoter of Einstein to a certain extent. A couple of other key things, and here's the quote I wanted to refer to. Asked, this is not necessarily attributed to him, although a lot of people think. Asked in 1919 whether it was true only 3 people in the world understood the theory of general relativity, Eddington allegedly replied, "Who's the third?" Meaning, Einstein, him, who's the third? But this was very true. There were very few people, probably just prior to and just after World War I, that truly understood Einstein's work. Anyhow, another thing too, and this gets a little bit into his philosophy, Eddington wasn't necessarily a metaphysicist. He wasn't looking at the spiritual aspects of science, but pretty much he was trying to make some connections with some of these things that he was discovering, that he was, gaining an understanding of. And he was trying, most assuredly, one of the things that came out a few years after Einstein's work was, starting work on the unified theory. Einstein certainly did it. And this isn't something that necessarily happened in the 20s. I would suspect more so in the latter decade or so of his life. But he was certainly interested in working on unified theory, but he was trying to connect it with what he called a fundamental theory, trying to numerologically make determinations with respect of trying to connect the big with the little. He never got there. His work continued. I mean, there was a book that was published, but pretty much the work was unfinished. But a lot of his had to work with, trying to determine these dimensionless ratios with respect to the weight of an electron, weight of a proton. Those were two key values in some of the work he did, and he was never able to get there. However, one thing that he was able to determine, and it was named after him, was what's called the Eddington limit. And this is the maximum star luminosity at hydrostatic equilibrium when the radiation pressure and the gravitational forces are in balance. Because we remember, certainly gravity is trying to bring everything down into the center of the star. And of course, the radiation and gas pressures are pushing outward. And there's a balance for a long period of time. And of course, different stars, sometimes, hydrostatic equilibrium becomes something else when stars either grow real big or they shrink down to minimum size. But under hydrostatic equilibrium, when there is a balance, like our sun pretty much is at this point. So, very intense radiation driven. Go ahead.
A little bit more simplified explanation of the Eddington limit is it's the equation that dictates how big stars can get and how quickly black holes can consume material from their surrounding environment.
Yeah, because when that limit's exceeded, that provides a little bit of the explanation behind black holes, at least accreting black holes and quasars. The limit isn't an absolute. I mean, certainly stars could be beyond that, but more than likely they're not in hydrostatic equilibrium at that point. So, but anything else, Connor?
No.
Okay, thank you. Okay, yeah, he was a prodigious writer. I can't see these anymore because my screen blocks these out. Oops, there they are. Okay, now I can see them. But you can see from 1918, and these weren't the only books. These are probably some of his more notable works. You'll notice the fundamental theory was actually published a couple of years after his death. But for the most part, he was the single author of each one of these. And these were books. There were a few more, but these are probably some of his notable works. But you can see they focus on, stellar composition, relativity. There's a lot of math in here, the constitution of stars. You get into the nature of the physical world. Here is some of his philosophy moving in, and certainly the philosophy of physical science. A lot of these books have been reproduced and updated publications, not necessarily editions, but have been, I think there are a few of them are probably still in print. Okay, now I gotta try to get, there we go. Okay, so moving on. Now, one of the things I mentioned, here we have this guy. He's, was well educated, did a lot in his field, both, in astronomy, physics, math to a certain extent. He's known for his astronomy and physics primarily. Of course, math is that background. But as far as a promoter of the science, and you take a look, here's one of his books, and it was one of the books that appeared on the previous slide. You can get a picture of when he wrote that one. But like I say, he was very much a science promoter. He was a member of the Royal Academy. He was a member of the Royal Astronomical Society. You can see here in 32, he's at an IAE, at an International Astronomical Union meeting in Plymouth, Massachusetts. There's a couple of notable names on there, but you can see it's a pretty august list. This isn't the entire attendance list, but just who this picture was taken with. But that's Eddington on the far left with some of his contemporaries. And this was very common. He lectured quite often. He lectured in a lot of different places. I think most of his work was at Cambridge. I don't think it was so much where he actually did classwork, but he lectured quite a bit, did a lot of research. But I think he was out and about. Talking to people, talking to his contemporaries, talking to his colleagues, talking to anybody that would listen, that would attend his lectures. And like I say, he was able to communicate a lot of this science, a lot of this math in, lay terms, understandable terms for those that weren't necessarily his contemporaries. And I think this is probably one of his most significant values as an individual, as a scientist, was being able to do that, because for the most part, you look at a lot of scientists back during this time and prior, there were very few people that could understand a lot of this work. And I think he did an outstanding job, at least at trying to make it understandable for not everybody, but even outside of his field. And I think that did a lot to promote science into the latter part of the century. Death and legacy, unfortunately, he passed away in 1944, so that would have been 62 years of age, roughly 61, 62. He had 13 honorary degrees from universities around the area. Most of them were science-based, physics, things of this nature. He never married, so he never had an immediate family. It was just his mother and his sister, but he never married. No small wonder, but you sometimes wonder because he certainly seemed to be the type of individual. He seemed to be outgoing enough and not just buried entirely in his work, but maybe he was. Numerous awards and honors. I mean, you take a look at his bio listing at the Greenwich Observatory listing for him, and there's, probably anywhere from a dozen to 2 dozen awards and honors. There's a lunar crater named after him and asteroid 2761. Probably most notable, and this is, of course, in Latin, is a plaque that was placed, his memorial, at the Trinity College Chapel in Cambridge. And of course, we provide the English translation for you. Of course, there's, Sir Arthur Addington, OM, Order of Merit. And you can see for 37 years, he was a fellow of the college, from the start of his fellowship, and then 31 years as the Plumian professor. So a pretty extended experience, I think. He was able to find a job and stick with it, but did quite a bit of good work. And you can see they make mention at the end of the plaque, as befitted a member of the Society of Friends, here again referring to his Quaker heritage. There are my references, and thank you for your attention. Questions, comments?
That was very good, Pete.